Today we are solving asteroid collision problem. We are given an array asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents its size and the sign represents its direction. Positive meaning right and negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. Two asteroids moving in the same direction will never meet. So asteroids moving in the same direction will never collide. Collision happens only if the asteroids are moving in opposite direction, positive and negative. In case of a collision, bigger asteroid survives and the smaller asteroid explodes. If both the asteroids are of same size, then both will explode. After all these explosions, we have to return an array of asteroids that survived. Let's look at these examples. In example 1, there are 3 asteroids, 5, 10, and -5. The first and the last asteroid are of same size but opposite direction. Let's see how many of these asteroids survive after all the collisions. The first 2 asteroids are moving in the same direction, so they don't collide. But the third asteroid is moving in the opposite direction. It will keep colliding with all the asteroids that are before it until it comes across an asteroid that's either of same size or bigger. In this case, asteroid before it is bigger, so the last asteroid explodes. Only 2 asteroids survive after all the collisions, that are 5 and 10. In the second example, both the asteroids are of same size but have opposite direction, so they collide. Because they are of same size, both of them will explode. In the third example, the first 2 asteroids are moving in the same direction, so they don't collide. But the third asteroid is moving in the opposite direction. It will collide with the second asteroid. Since the second asteroid is smaller, it will get exploded. The remaining 2 asteroids are also moving in opposite directions, so the third asteroid will collide with the first asteroid. Since the third asteroid is smaller, it will get exploded. Finally, after all the collisions, only the first asteroid survives, and we return the array with only first asteroid. The algorithm for this problem is straightforward. Because we know that a collision can happen only when an asteroid moving to the right comes across an asteroid moving to the left. So we parse the asteroids from left to right one by one. If the asteroid is moving to the right, we add them to the stack. If the asteroid is moving to the left, then we pop asteroids from the top of the stack until we get an asteroid that's either moving to the left, or if it's moving to the right, but larger than or equal to the size of the current asteroid. If we get an asteroid that's moving to the left, that means we can add the current asteroid to the stack. If we get asteroids that are moving to the right, we keep popping them from the stack until we get an asteroid that's bigger in size. That means the current asteroid will explode. Or if we get an asteroid that has the same size as the current asteroid, in that case, both of them will explode. So we pop that asteroid from the stack. We repeat this process for all the remaining asteroids and return the remaining asteroids in the stack in reverse order. The runtime complexity of this algorithm is O of n because we push each asteroid once to the stack and we pop each asteroid once. And the spacetime complexity of this algorithm is O of n because in the worst case, we may be pushing all the asteroids into the stack. Let's write the code for this algorithm. First, we define an empty stack. Next, we go through asteroids one by one. For asteroid in asteroids, if the asteroid is moving to the right, we add it to the stack. If asteroid is greater than 0, which is it's moving to the right, in that case, we just add it to the stack. Or if there are no asteroids in the stack, if if the stack is empty, we add the asteroid to the stack in that case as well. So we continue. If the asteroid is moving to the left, we go through the stack and pop all the asteroids that are moving to the right because they will collide with the current asteroid, which is moving to the left and has a smaller size. So while stack and top of the stack is moving to the right and the size of the asteroid at the top of the stack is smaller than the size of the current asteroid, we pop the asteroid from the stack. Stack.pop. Now, if the stack is empty, or if the asteroid at the top of the stack is also moving to the left, then we add the current asteroid to the stack. Else, the stack is not empty and the asteroid at the top of the stack is moving to the right. So in this case, that asteroid is either bigger than the current asteroid or of the same size as the current asteroid. If that asteroid at the top of the stack is of same size as the current asteroid, both of them will explode in the collision, so we pop it from the stack. Finally, we return our stack. Let's try to run the code. It passes all the test cases. Let's submit the code. That's our final solution. If you found this video to be helpful, please support the channel by liking the video and subscribing to the channel. I will see you in the next video. Thank you.